So let's kick off by sharing my screen. Hopefully you can see the presentation now. And the session today is going to be Azure loves containers. Few things about me first. My name is Mustafa Toroman. I work as a solution architect with the company Authority Partners. It's a US company, but we have kind of presence all over the world. Big development center in Sarajevo. We actually have one in Turkey, in Istanbul as well. Here is also my Twitter handle. If you feel I could help you in any way, I will try to answer your questions, or at least try to point you in the right direction if I actually don't know how to help you directly. I've been Microsoft Azure MVP for 5 years now. I'm very certified in Microsoft technologies. Been Microsoft certified trainer for almost 5 years. Sorry, almost 10 years now. So on, not to count those things. Okay, so let's start with containers in Azure. But before we begin, let's remember a couple of things, a couple of details on containers in general. Why containers? How come we came here? Why do we need them? First reason why we would like to use containers and why we need them is very famous sentence I heard many times in my career is, "It works on my machine." As someone who is really dedicated to DevOps, believes in DevOps, and that we should using it, this kind of really hurts my soul when I hear "works on my machine." Now, containers are an option, and containers very well go in hand with DevOps to this problem. It should resolve this. We are targeting a specific piece, and we are not dependent on specific environment, especially on the developer machine anymore. So basically, what they bring in here is that every environment looks the same. We always have the same environment, no matter what's going on. The environments, it's always going to be exactly the same. Now, it also helps us to increase velocity. They are really cool in terms of speed, scalability, and all different kind of things. And the most important thing that we need to remember about containers is that they can run anywhere. Like, basically, that's the idea of the container in the first place, that we can have a totally agnostic application that doesn't really depend on any kind of platform. We are able to use it always and everywhere. Whatever our platform is, we should be able to run our containers. So where are they able to run? So basically, it all started with Linux, like container story developed in the open source community, and everything started on Linux. So basically, containers are native to Linux environments. But later on, Microsoft picked up on the story, and they worked heavily to introduce the same thing on Windows. And this is where Windows came to the story. And now we were able at some point to deploy our application either to Linux or Windows environment. It wasn't really matter anymore what the underlying host was. We could run it basically on two most common operating systems there are. Then cloud came out to the story, and cloud is kind of a big thing on this. A lot of people, when discussing cloud, when moving to the cloud, are considering, are they going to get provider locked? If they go with any specific cloud provider, is it Microsoft, Amazon, Google, what's going to happen to their application? Like, if they heavily invest in developing there, are they going to get stuck with the platform for many years, because refactoring and moving to a different environment would cost a lot of money? Now, containers, again, are the solution to the problem, because, again, they can run anywhere. It doesn't really matter where are we hosting our containers. They should run pretty smooth in any of the cloud providers. Most popular container service that we have now is Kubernetes, and that started with Google. But in the meantime, both Amazon and Microsoft worked on their solutions, so we have native Kubernetes service there as well. So basically, it really doesn't matter which cloud we pick if you're moving on with the containers, because it should be fine. And finally, and very interesting thing to that is that basically they can run on a variety of devices, because they basically support any kind of operating system. We can set containers to run on drones, on Raspberry Pis, on any kind of IoT device. So it's a big step forward and allowing us to do basically any kind of work, any kind of development on containers, because the variety of devices that can run them is insane. Basically anything. Now let's look at the story how containers and virtual machines relate, because especially when we discuss system engineering and how they approached a container story, there was a lot of arguing that basically they don't provide any real value. This is simply not true. Like, virtual machines really did bring revolution to IT. Virtual machines and virtualization in general allowed us to set up multiple environments, multiple machines on single piece of hardware. And today, I don't know anyone anymore who actually runs any kind of server on physical machine. Like, anything that's kind of abstracted and accessed directly it's on top of some kind of hypervisor. And this story with virtualization brought story of the cloud as well, because none of it would be possible without virtualization. Now, the story that was like when we introduced the containers, a lot of engineers kind of oppressed it and said it doesn't really bring any value. Now, what they have in common when we look at virtual machines and containers is that they share infrastructure and they share host operating system. Now, this is where all similarities end. What we had on virtual machines is basically on the host operating system, we will run hypervisor and basically built multiple virtual machines on top of that. And all those virtual machines would basically be separated completely and independent. Everything that we are sharing is basically only infrastructure. Each virtual machine has its own operating system, or bins and libraries, applications. Everything was separated. What containers bring to the story is that they are not using a hypervisor anymore. They're using container runtime. And basically, containers only keep bins and libraries inside a separate unit and application that we are deploying on them. So basically, all the components of the host operating system are reshared between the containers, and they are reused. Because of that, containers are much more lightweight and they are more portable than virtual machines. The argument that people had for virtual machines is, yeah, I can just clone as many virtual machines as I want. Yeah, but those virtual machines had a huge fingerprint. Like, if you wanted to just clone multiple virtual machines over and over, as many instances as you want, you would need to copy gigabytes of data, sometimes hundreds of gigabytes of data to replicate that virtual machine. With the containers, we are only using we have a small footprint, because only bins and applications are kind of unique for the container. Everything else is shared between the container images and used from host operating system. And because of that, at sometimes we have only few megabytes of container footprint. Size of a container can be only a few megabytes, because everything else needed to run it is in the background. Okay, so how building containers actually work? So as layer 1, we're going to have some kind of, I took example for Windows Server Core, but it doesn't have to be, like any operating system will do. On top of that, we're going to have some, I don't know, like I took example again from IIS because it's a Windows server, but we're probably going to have any kind of a web server in place. If it's Linux, it's going to be Nginx, Apache, or whatever else. Then on top of that, we're going to have as a layer 3, for example, ASP.NET. Now, it doesn't have to be ASP.NET. It can be any kind of framework, because any operating system, what operating system supports it, container will support as well. And then as a layer N, because we can have this abstract up and up, basically depending on how our structure is and how much components we can actually reuse. As the last component, we're going to have some websites, some kind of application, some kind of code. And this is the like the biggest abstract that we can separate and have, like, our application is containerized. It has some kind of dependencies, so we have to make sure what is in the background, what kind of dependencies are used, but everything is reused. We want to reuse as much as things as possible, so this last layer is separated as only the application itself. Here in the mix comes a thing called container registry. Now, with the container registry, we can push the images that we are building for the application and use them as a central place where we can distribute the image as much as possible. So we are in a container registry. It's basically a repository for storing container images. There are multiple options out there. We can use Docker Hub for the public registries. Keep in mind that everything published to a public registry will be available to everyone. So if something that you earn money on, you probably won't push it there. But we have also private registries that allow efficient and secure storage that we only have access to and use as much as possible. Now, what are actually, let's stick with the container registry. Let's do a quick setup of application window. Let's see. So let's do this one. So let's set up container registry right now. So I'm going to be in Azure, and I'm going to do like container registry. I want to create one. Okay, here we are. Let's create a new research group for this. We'll call it container demo. Container demo. Okay. Let's do a name for it. Let's call it. Demo. It will probably not work. Yeah, as I imagined. Let's do, today is 28, so let's do 28, container demo 28. Now for the location, you can basically choose whatever you want, but based on your location, if you want best performance, less network latency, you probably want to use one closer to you. So let's do, like, I don't know, West Europe, which is pretty close to me. Let's stick with basic tier. It's for demo. I don't want to overkill it. Now let's show a little thing. If I do standard, for example, it doesn't want. So let's do a premium. So premium supports private networking, so you can basically secure it in the private network without ever exposing it outside. But that's only for public. Let's do a basic one. As I said, it's for demo, and I don't want to overkill it. And basically, that's it. That's all I have to do, and it should deploy relatively quickly. But let's not wait too much on that, because we'll probably don't have too much we will probably not have too much time to finish everything I would like to show you. Oh, actually, it already deployed. Okay, that's cool. Now, a couple of things that you can see, like there are multiple things that we can set up here, informations. Now, one of the things that you really want to see is logging server. So this is the one that you might want to use at some point, especially if you're using something out of Azure to build and deploy. So if you're using, for example, Jenkins, or I don't know what, there are multiple cool DevOps tools. You probably want to remember this one. Also, you want to check out the access keys. Like you can see, okay, you cannot see them because I have a plugin right now, and it's a really cool one. If you're using Microsoft Edge and you're using any kind of presentation, there's a AZ Mask plugin that can basically hide all your sensitive information. So this one is basically you have a registry name. Let's actually, I'm going to destroy this anyway, so let's toggle it on. So we have a registry name, we have a login server, and we can actually enable admin user as well. Now, admin user will create a username for our container and create a password as well. So that's part is cool. Okay, so that's the interesting part, and basically there are multiple other options, like you can do custom encryption on your containers, so you ensure that they are protected at all times. You can do manage identities using a Active Directory to access it. There's also option for networking. Now, networking, as I said, is kind of, for the private endpoint, is limited only to premium tier. We have security options. Now, a really interesting part is that you can see repositories, webhooks, replications. Now, this part is right now empty because we just created it. It's not connected to anything yet, but it will be in a few minutes, and we'll get back to that after a while. Okay, so let's move back to presentation, and where we were like, let's discuss containers in Azure. There are multiple options. There are many things that we can do with containers in Azure. We have options to run containers using app service, which is really cool in my opinion. We have options for the service fabric. We have Kubernetes service. We have container instances, and we have batch. Now, batch is kind of a specific, and it's not intended for long-term workloads. Batch is kind of a thing that you want to run for a scheduled job, and you have a huge amount of tasks. You have a huge amount of computing power required for it. So batch is one of. It can run containers, but it's not kind of thing that you use generally and for each kind of applications. Now, in this list of options for containers in Azure, let's start with Service Fabric. So Service Fabric basically supports Windows and Linux containers, is stateless and stateful. It uses stateless approach and stateful microservices, and it can deploy on Azure Stack, and on premise. Now, it's just so interesting to say that there's an update for Service Fabric Mesh, which is more managed than this one, but it basically gives you a lot of options and how to set up. Now, Service Fabric was a container before it became popular. What a lot of people don't know is that Service Fabric is something that Microsoft uses for Azure as an internal tool. A lot of services in Azure rely on Service Fabric. For example, Azure SQL databases are relying on Service Fabric entirely, and so on. There are many services inside Azure that completely rely on it. And it's basically something, when we discuss Azure, where containers started, and this is something that was first available. Now, through the time, it developed, and it's still developing. A lot of people were concerned that once Microsoft started introducing new kind of container service in Azure, that this one will kind of get deprecated. I don't think it's going to happen anytime soon, because simply Microsoft is relying on itself for a lot of things, and basically to just cut it off, they need to switch to other services as well, and it will require a lot of time and effort, and I don't see a benefit to replace something that worked really well. So what Azure Service Fabric does is basically it helps you deal with the complex situations. It completely supports microservice development, and MySQL microservices are something I'm also a big proponent of. Along with the DevOps, microservices allow us a lot of different things, a lot of cool stuff to implement DevOps, because same as what containers brings us, microservices are also offering small footprint, small deployment times, less downtime, uh, better scalability, and so on. So basically, microservice architecture and containers are basically tied together. It's, if you're using one, you should use the other as well. So it's simple as that. Okay, so let's see what we can do else. The next thing that came to Azure in terms of containers was Azure Container Instance. It was a really cool feature for a while, but at some point Microsoft decided to cut it off. It brought option for the first time that we can run Windows and Linux clusters on the same nodes. We could have mixed environments and so on. So it was a really interesting setup, but along came different options and it was kind of cut off. Now, so basically, because it's cut off, no future development on that, I'm just going to skip to the next one and say a really cool thing that we can do is run containers on the Azure App Service right now. Now, I'm really excited to say that, because running containers on Azure App Service is one of the most interesting feature I heard that was coming to Azure in a long time, because I'm a big fan of Azure Service, Azure App Service in the first time, in the first place to start with. It's one of the best things it happened. Like Azure App Service was one of the first services in Azure, and it's really cool. It's developed in the right direction. It offered you a lot of things and basically allowed you to run your application in a platform as a service model without worrying about underlying server. And bringing container options to the table was something even cooler. So what we could basically do is we had a really cool deployment cycles on how we can actually set up our applications and how can we actually work with containers. Now let's quickly switch to that one as well. Let's set up our, so this one, I guess, yeah. So let's quickly create an app service for containers. So app service. Actually, let's do like web app. So let's do a web app. We're going to create one. Okay, we're going to use, what was the name of the resource group? Container demo. Okay, let's do a container demo app service. It's too long. Okay, container demo app service is this. Now, during the selection, we can set up to do a Docker container. And now, in the past, we had only Linux, but recently, Windows ones were available as well. So we can do either Linux or Windows. It doesn't really matter. As I said, it's a container and should run anywhere. But one thing that we need to keep in mind that when running Azure App Service, Linux App Service is cheaper than the Windows one. any kind of service that runs on Linux is always a bit cheaper because you're not paying license for the operating system as well. Okay, let's use West Europe as well. I'm going to set up this as a default. I'm not really concerned about it. Now, what's really cool is that here I can set up options for the containers. So basically, I can select a single container. I can do a Docker compile, which is still in preview, but no matter what. And I can see different things. Like I could do a quick start, Azure Container Registry, Docker Hub, private registry. So basically, if I select Azure Container Registry, it will offer me to select the container registry I just created previously. But I'm not going to do that. I'm not going to do it from one simple reason. I want to set up deployment pipelines by myself. So I'm just going to skip this and say, okay, just deploy a quick start container for me right now. I don't really care about it. And it's always slower when you're trying to okay, just let's do a review and create. And let's create it. Okay, deployments is going to take a minute or two. So in the meantime, let's move on. Now, as I said, it brings a lot of cool things. One of the things I really like about it is built-in CI/CD with deployment slot options, where we can set up multiple deployment slots, have different environments set up under same app service with no extra cost. We can set up automatic scaling. We can set up basically automatic scaling comes with built-in load balancing, so you don't have to take care of that. It's completely like it basically managed service, and you have less things to worry about. Your thing is to deploy the code, and everything else can be managed, set up to be done automatically in the background for you. Okay, so let's move back to the presentation part and move on. So one thing that we can, as I said, multiple tools, multiple options, you can do whatever I want. I could basically set up this with container images as a container registry as well. And basically you saw that there is an option. I could just hook it up and it would be like automatically connected to container registry. But I don't, as I said, want to do that. I want to do full pipeline by myself, just to show you how it actually works. And let's now move on to the last point and to the last option that came to the table, and basically Kubernetes and Azure. Azure Kubernetes Service is basically last option that was introduced as a container service in Azure, and it's kind of cool. It's the coolest thing to talk about right now, because Kubernetes offered a lot of innovation when it comes to container world. As I said, mentioned in the beginning, it started out in Google. Google started developing Kubernetes. It grew from that. It became a community project, and basically all cloud providers are offering some kind of Kubernetes service right now. So what it actually brings, it's fully managed Kubernetes service. Azure Kubernetes Service is fully managed. So basically, it does everything for you in the background. Again, similar to the app service. It does elastic provisioning. It also fast end-to-end deployment. Again, containers are really cool. They go hand in hand with microservice architecture because they have a small footprint and can be easily deployed very fast, because we are just doing chunks, not doing a whole application at a time, and so on. They can be managed completely with Azure Active Directory, so it's also a really cool thing because you don't have to rely on external login, remembering passwords that are just dedicated to couple of services. It's perfectly fine when you're playing with it and you have like one Kubernetes cluster deployed in your environment, but when you can have hundreds of them and have to keep somewhere hundreds of usernames, passwords to access each of them, it's kind of a issue. But if you're using Azure Active Directory, then you can basically use role-based access controls, allow certain people to access it, and so on. So it's much easier to control when you're using your corporate account with it. Orchestration is offered across 29 different regions. I kind of think it's moved from that. I think we're all already at almost 40 right now, but whatever. It also supports Azure Stack and IoT as well. So elements of the orchestration, we can do scheduling, we can pre-schedule the any kind of maintenance, any kind of scaling. It has options, automatic options for affinity and anti-affinity. It has built-in health monitoring, so you know the cluster itself is monitoring the nodes, and it has also options for self-healing, automatic failover, automatic scaling, that can be based either on scheduled scaling or performance-based scaling. Networking in the background is also done for you. You have a DNS server set up, so on. You have automatic service discovery, coordinated upgrades, and so on. So that is like really couple of really cool things. Now let's move back to the browser. And that's probably where we're going to stay until end of this session. So in the meantime, web application deployed. So let's just move on and say, okay, I want to do AKS, or will be Kubernetes service. Oh, here it is. Okay. So Kubernetes service, let's deploy a Kubernetes service quickly. So let's do a resource group. We'll do the same one. We'll call it AKS demo. Let's do, okay, West Europe automatically. Availability is on. We're gonna leave that on default. Node size default. Nodes, we can play with that. We can set up authentication. We can play with the networking as well. Now for the networking, it's also interesting to say what you want to do. What kind of networking configuration you want. You can set up DNS prefixes, traffic routing, and so on. I'm just going to leave that at default, but there are a lot of different things to play with when we are discussing Azure Kubernetes Service. Okay, let's review and create. And we are good. Validation passed, we can start the deployment. Okay, this is probably gonna take a while. Now, in the meantime, let's see what our app service offers. So if I open my app service, one thing that I have in here is kind of the URL for the application. Even if I go here, it's just like the basic, the blank website. It's just a HTML place right here. So you know that your app service is running. Now, really cool thing that we have in here is that we can set up different things. Now, I already mentioned deployment slots. And basically, we can do a deployment slot. All we need to do is to say, okay, add slot. We can add name. And basically, the very cool thing that you can do with the slots is to clone the original app. Now, it doesn't really have any purpose to do this right now, because this is empty one. I didn't have any kind of deployment. But if you are doing, like, if you do a first push of code and you want to clone these environments multiple times for dev, test, QA, UAT, staging, whatever you want, you can have as many instances as you want. And basically it allows you just to clone each of them to have initial setup, and then you can start working on the CI/CD pipelines to set up everything in place. So it's a really cool thing. This is kind of not a so old thing, but it's also cool that it works with the containers. That's what I wanted to show you. Now, also what we can do is basically do a scale out, horizontal scaling, that can be set up for our app service. And again, it works with the container instances, where we can do a custom rules and say, okay, I want to add a rule. Come on. Okay, so I can add a rule that will, in case that my, I don't know, in this case CPU, okay, that's a good metric. If my CPU goes over 70, add one instance of my application to the count. Now, what you also want to do, if you're doing this, what you really want to do is to have a scale down option as well. Because if you're just doing scale up, it will add a new instance when your CPU is on over 70%. But if you don't add a rule to drop an instance once the CPU is back to normal, you will just pile up app services over time, and not you will end your build can kind of end up insane in that case. Okay, now let's move on. Okay, deployment of the AKS finished as well. That's cool. So let's look at that one as well. Okay, so here it is. I have my container running. I have nodes here. Namespaces should be empty because I don't have anything, maybe default only. Yeah, I have a default ones. Workloads, I can see services and ingress and so on. But also one thing I would like to show you, that so basically my resource group is called container demo. And if I go to my resource groups, there are quite a lot of them. There's going to be, yeah, here it is. So I have MC Container Demo, AKS Demo West Europe. This was created alongside with my Kubernetes service. And it basically creates a virtual machine scale set that will run, which will back up my containers, my Kubernetes service. So basically, it deploys network security group, route table, virtual machine scale set, virtual network. We have a public IP address here as well, and we have a Kubernetes load balancer. So let's just check. This one is internal, I think. Yeah, this one is internal. Okay, that's cool. Let's move on to how to set up a deployment for this now. Okay, so let's do. I have a repository named AKS. It's a simple app. Let me see which one this one is. So this is just Node.js. Okay, a simple Node.js app. Let's do a new pipeline. Okay, so I'll create a new pipeline. And basically, there are a couple of options. I can do YAML, or I can use a classic editor. Now, this one will basically ask me to select my repository and then recognize everything I have in there and set it up. Now, the thing I need to set up here is to provide Docker registry endpoints and so on in order to be able to work. And this is really cool option if you're running like production pipelines. I really like YAML because they treat your pipelines as code. So basically, any change is tracked in the same way as a code change is tracked. So you know who changed the pipeline, when was it changed, so on. So it's a really cool option. Another thing that's really cool about YAML pipelines is basically they travel with your code. So if you decide to move to another repository, to another service, to another project, you can just bring everything with you, and your build will be there as well. So it's kind of a cool thing. Now, I don't actually want to do this. I will do a fresh new pipeline. So let's do a classic editor. And I'll say, okay, I want this repository, I want this branch, that is fine. And I'll say I want Docker container. So I'll just build the Docker container right here. And it will ask me a couple of things. I need to provide my Azure subscription. So this one is good. It will ask me for the container registry. So the container demo 28 we already created. What else do I need to do here? Let me see. Okay, that's good. Now we need to push the image. We'll use the same one. We'll use the container demo. Okay, that's cool. Is that it? Advanced options? No. Build image. Container demo. That's good. That's good. That's basically it. I can save, queue, save and run. And this will run my pipeline. This will create my first release to my first build for my Docker application. This kind of takes a while, but all good. Okay, while this is running, let's do another thing. Like I'm creating a build, I'm pushing, like I'm building here what I'm doing here, and maybe it's better to show here as a so edit. So what I'm doing here is basically a building an image and then pushing it to a container registry I previously created. Then what I'm going to do in the next task in the release, I'm just going to pull that image and just like throw it to my AKS. So that's kind of a cool thing. Now we can reverse engineer this. We can do it other way around, and that's a really cool thing in Azure right now. And let's go to my container demo. Let's go to my app service. And we have an option called here deployment center. Now remember that when I selected my application previously, we had to like set up that we want to container. So this option, I will use my Azure repos. It will ask me, okay, it will recognize that I have a Docker application, Docker build right here. I will move to, it will recognize that I have a app.doc file. It will then move, okay. I can either create new container registry or select existing one. It already detected that there's a container registry in that resource group, and I'm done. Now this will create a new pipeline for me automatically. I don't have to do anything. All I had to do, I had a code in Azure DevOps. I had I created app service. I created a container registry, and it ties everything together. It doesn't. I'm not bothered with it anymore. So let's see what's happening in my pipelines in the while. So this one was completed. So the deployment was done. Let's do a release on this one. So let's do a new pipeline. I'm gonna do a new release pipeline. And I'm gonna say, okay, I want to deploy to Kubernetes cluster. That's good. Now it's gonna ask me a couple of things. So I need to create a new Kubernetes service connection. It's always using something. So okay, no, not this one. I want to use my account. Okay, that's good. That's good. It's gonna ask me for MFA confirmation. Always have an MFA on the account you're accessing your resources with. Okay, that's good. It should get authorized. Oh, come on. I took a wrong subscription. Okay. I selected wrong subscription for this one. Okay, that's cool. Again, need to approve. Okay. Okay, so it recognized my cluster. I can use any namespace that I want. I need to create a service connection name, and that's basically it. In the second part, when this is done, what is left, I need to set up a secret. So I need to say, okay, on my subscription, I need to do which container. I'm done. And I can create a release for this one as well. So release one was scheduled. So this one is queued. Let's see what's going on with our app service. Okay, so it says that everything is set up. Let's see what is set up in our world. So in the pipelines, you can see that it created a new build for me. Now let's see what this build inclines. Let's quickly edit this build. And it's basically the same step I did previously. So basically the same one I used for AKS, it used exactly the same one. So basically it's the same build process. It doesn't really matter where you're going to deploy it. The build is always going to be the same. It's always going to be like building an image and pushing it to some kind of repository. In our case, it's Azure Container Registry, but it can be basically Docker Hub or any kind of private container registry that you want to use. Okay, so let's go to the releases, and this should created, yeah, here it is. So it created a release process as well. I can see, like, let's see what happened in the pipeline, edit tasks. So here I have some kind of Azure CLI, container registry secrets. So it's setting up, warming something up for me, and then it's actually deploying to my container registry. Okay, so that's cool. So this means that my application is already done and deployed. So if I do run this again, let's just move here and set it up. Okay. Oh, it's not. It usually is like that. So let's see. It takes some time to warm up. Okay, let's see what happened to another release. So the last release I did, this was the one. So my Kubernetes, was this the one I created? Let's see. The Kubernetes finished as well. Now, I won't be able to actually show you what was deployed in the Kubernetes because the Kubernetes one was deployed with the internal load balancer. So if I go to my Kubernetes, where am I? Okay. So if I go to my Kubernetes and go to service and ingress, you will see that I have a couple of services up and running, but all of them are actually running on cluster IP addresses. I don't have an external IP address. To actually set this up and to actually have it accessible over internet, I would actually have to deploy a public load balancer and set it up that way. So that basically I have a public access to Kubernetes as well from the outside. Now the thing is that both of those services offer really cool thing. Is this done in the meantime? Yeah, here it is. So hello world. This is just a basic demo. I just used the Node.js one pager so the build would end up faster. I wouldn't need to wait for like an hour and a half for the build to finish. So basically I would recommend going with both of these options because both AKS and Azure App Service offer a really cool thing. But in terms of if you're running with the complexity and you have a complex microservice architecture in the background, I would go with AKS because they offer a lot of cool things in terms of communication because everything is set up on the private network. It allows you to have communication between microservices basically over private secure connection, not exposing them over the internet, because in that case you can just expose certain things like a web interface and stuff without exposing microservices directly out. So that's kind of a good approach if you're running that. But if you're doing like just a single container application without microservices, app services is definitely a really cool way to go. Okay, I hope I'm not too much over time. And do we have any questions?
Okay, let me jump over there and see if there are any questions that I need to translate. I didn't see any, but let me take a look at it. Okay, guys, any questions? I don't see anyone hanging out there in the list. Okay. In that case, I guess we are good. Would you like to share some, your Twitter profile or something in case they have questions after the session so they can
Absolutely. Just give me 1 second. So I had it on the first slide, but let's like repeat that again. Where was it?
They might be just shy of, asking live. They might prefer.
It happens a lot. Kind of with online thing is people get a little estranged, let's say. I really prefer live events, talking to people in person. It gives us much better interaction, much better discussions. This is kind of I don't know, estranged. We are I'm in one place, I'm in Sarajevo, you are all over Turkey, I presume. I don't think people are in a single city. So
yeah,
but let's hope this will be behind us very soon and we can actually do this in person next year.
Okay, yeah, I hope so. There's a lot of thank you messages coming through, so that's a good sign. Yeah, thank you for taking taking the time to present this. This was from my perspective, this was very educative and, a nice, really good presentation. Thanks for that. We will be sharing the recording of this one once we got the whole thing done, and we're going to be, we will go through this and start editing and splitting things. So we will share that because I see some people are mentioning that they didn't, they just joined us in the middle of the session, so that should be okay. You should be able to go back and watch the whole thing. With that, thank you again. Thanks for your time.
Thank you for inviting me. Thank everyone for their attention. It was a pleasure being here with you. Hope you gain something interesting from the session, something that you can do use in your job every day, and hopefully, let's see. I don't know. If there are any questions, please reach out to me over Twitter. I will try to answer them.
Okay, with that, we're gonna give a 4 minutes long break and then we will be back with another session.
Okay, thank you again. Enjoy the rest of your day. Bye.